All right, here we go, homework 5-4. Let's see. In this section, we're going to use this a lot, this formula a lot. Probability of A and B equals probability of A times the probability of B given that A occurs. So on 4, we've got probability of E and F are two events. They tell us what E and F is, and what E is, and what's F given E. So if we look at, instead of A's and B's, we write this in terms of E's and F's. And I can write this two different ways, so I want you to see this. E times probability of F given E. Or I could write it like this, probability of F and E, because these two are the same, right? That's the probability of F times the probability of E given F. Okay, so either way that you write it, these are the same thing. It all depends on what you want. Do I want F given E or E given F? Okay, I want F given E, so I'm going to use this form or version right here. So I've got E and F is 0.21, E is 0.4, and probability of F given E. So I divide both sides by 0.4, and I get probability F given E is 0.525. Okay, so that was 4, 5. Two events. Okay, so this is the same type of thing. E and F, F given E, so it's just more practice on the same thing. So for 5, we've got N, though. N is the number of things, is 420. The number of things is 740. What's the probability? So how are we going to handle that guy? Well, I don't know if you remember when we did the Titanic problem on the board, but we solved, or we looked at this. We said the probability of crew given survived was, we looked at how many people survived, because that's all we're interested in, the number survived over the number of people in the crew and who survived, right? Because if it's given survived, we're only interested in the people who survived. And then of the people that survived, how many of those were crew? Well, that's crew and survive. So for this, we want the probability of F given E is, well, given E, how many people were in E? We've got 740. And of those 740, how many of them are E? Well, of the 740, that's E and F that are both E. So you got to be E and F. So that's 420. And that's going to end up being 56.8%. Okay. Now I could have written this, the probability of E and F over the probability of E, but and I'd have gotten the same thing, but I don't need to do it that way. So number 6, probability of F given E, right here, is, I'm only interested in E's. How many are E's? 925. And of those 925, how many of them are F's? Well, that would be E and F, which is 380. Okay, and that's 0.411. Okay. And 7. E and F are two events. E is 0.8. F given E is this. What's P of probability of E and F? Is probability of E times the probability of F given E. And let's see, that's what we've got. So we've got probability of E is 0.8. Probability of F given E is 0.4. It's going to be 0.32. Alright, so let's look at 8. E and F are two events. E is 0.4. F given E is 0.6. What's E and F? So same type of thing. Probability of E and F. Probability of E times probability of F given E. So probability of E is 0.4. F given E is 0.6. So E and F is 0.24. Okay, and number 9. Create a U.S. Census Bureau probability that a randomly selected head of a household earns more than $100,000 per year is 20.2%. Wow. Probability that a randomly selected head of a household in the United States earns more than this, given that they have a bachelor's degree, is 41%. Are the events earned more than $100,000 and earned a bachelor's degree independent? Well, for them to be independent, well, here, let's write down what we have. Probability of greater than 100,000, this is 9, is 0.202. Probability that they earned greater than 100,000, given they have a bachelor's degree, is 0.412. So somehow, well, here's a question. Does having a bachelor's degree affect the probability that you make more than $100,000? And the answer is clearly it does, because you have almost double the chance of making more than $100,000 if we know that you have a bachelor's degree. Okay, so there is some sort of association there, so they are definitely not independent. All right, so there you have it on those guys.